Hi, everyone. Thank you for joining today's webinar. Today, we will talk about the best practice of fighting against the DDoS attacks and what is so special about auto-scaling game servers. For today's session, we will cover four topics. The first one, current challenges for battle game operators fighting against the DDoS attacks. And then we will talk about the solutions of proxying battle servers for the entire life cycle. And after that, my colleague Robert would also share some insights about the new solution from Tencent Cloud, tunneling client-server connection through the VPN. And lastly, we will also cover some current use cases. So for the first chapter, I will go through some of the challenges the battle game developers would encounter. For most of the online games, mobile, MMOS, FPS, they all would apply the same following infrastructure on the right-hand side. So typically, the lobby server will be hosted on a single cloud. But when it comes to battle servers, to mitigate the risks, usually game developers would prefer using multi-clouds because of the multi-cloud setups. The first major challenge is how would you protect battle servers that are scattered across different cloud providers? And unfortunately, that is not the only challenge. Many battle servers are auto-scaling, spinning up and shutting down based on players' demand. Well, this is great for efficiency and cost control. It also means the protection layer has to constantly adapt to new IPs and new instances, which makes protecting them much harder in practice. And now, apart from the multi-cloud challenges, there are a few other big pain points for battle game operators as well. And first, games needs very low latency. Network routes often cross multiple countries, ASNs, and service providers, making quality unpredictable. For real-time games, even small delays can cause lags or disconnects, driving players away. And second, there's a high risk of DDoS attacks. They are cheap to launch nowadays with just tens of US dollars. Attackers can trigger over 100 gigabits per second. The number of large-scale attacks is growing every year, and gaming has already become their prime target. And lastly, the new game releases often mean huge downloads, over 10 gigabytes, which can cause sudden traffic spikes if not managed well. This can overload CDN capacities, slow downloads, and lead to user losses as well. For example, one Tencent game reserves 1.5 terabits per second of bandwidth just to handle the launch traffic. So for the second chapter, how do we deal with the challenges I have mentioned above? We will talk about proxying battle servers for their entire life cycle. Now let's talk about how Edge One brings security, acceleration, and edge computing together for game customers. It is our next generation CDN platform built on years of Tencent's experience in DDoS mitigation, web protection, and bot management. On the top of that, it also supports edge function computing, so you can run business logic closer to players for faster and more secure access. What is more powerful here is that Edge One deploys protection right at the edge nodes closest to users, blocking malicious traffic at the source. It offers layer 3, layer 4, and 7 end-to-end protection and accelerations, covering everything from web content to in-game traffic. So this architecture supports anycast scheduling to direct the user to the nearest node and proxy-based forwarding for L3, 4, 7 traffic, and terabits per second level protection and tens of millions of QPS capacity. Security features like CC attacks preventions, vulnerability protection, and bot management, dynamic and static contents accelerations, large file downloads, and origin protection. So in short, it is a single platform that keeps both your battle servers and platform services fast and secure, no matter where your players are. Here's how Edge 1 a dedicated DDoS protection works. So players' traffic is routed to the nearest cluster, whether that's a region A, region B, or region C, using anycast scheduling. And from there, it passes through our fast tunnel and intelligence routing to the endpoint node with the best pass back to your origin server. This setup works for both on-premises and cloud beta servers, and it is built for massive capacity up to 15 terabits per second for overseas attacks and over 1 terabits per second for attacks from within mainland China via our Beijing, Shanghai, and Guangzhou scrubbing center. It is very ideal for L4 TCP or UDP traffic, which is exactly what most real-time battle games relies on. As for our next solution is to use anti-DDoS elastic IP. It is a simple three-step process. First, you need to create an anti-DDoS Pro instance. And then you need to create an anti-DDoS elastic IP and associate it with that anti-DDoS Pro you have created previously. And finally, you can attach that elastic IP to your beta server. Once that is done, all players' traffic from matchmaking to actual gameplay goes through the anti-DDoS layer first. And looking ahead, we are also automating this process for auto-scaling. This means when your battle servers scale up or down, the protection binding happens automatically. By that way, it saves a huge amount of manual work and ensures every new instance is protected from the moment it goes live. And now here's the key to success for this elastic IP solution. And normally we have two versions of anti-DDoS product. One is the standard version, and the other one is mentioned previously, the enterprise version. In a standard setup, anti-DDoS Pro protects traffic, but the capacity is limited to a single node. So if the attack is too large, the server can, there's a small chance the server could get blackout. With this enterprise setup, we replace the normal elastic IP with an anti-DDoS elastic IP, so the traffic can route through a large scrubbing center nearby. This gives much stronger protection and keeps the service stable. One important point here is that most games can't change server IPs after launch. Once the matchmaker has the IP, it is pretty much fixed. So you need to plan which setup you will use from the very beginning. In the next chapter, my colleague will continue with the new solution. And Robert, you can take it from here.
Now that we have addressed the initial challenges and basic protections, let's smoothly transition to part 3 of our talk. In this section, we focus on advanced solution provided by Tencent Cloud Edge 1 to secure and accelerate beta servers. We'll be looking at tunneling games connections through a VPN-like channel, a multi-channel acceleration scheme with an SDK on client. So let's take a look at the multi-channel security acceleration scheme. Well, on the left side of this slide, you can see the topology diagram illustrating the solution's principle. So by installing an SDK on customer's game client, including Windows, Android, and iOS platforms, all game client server connections are tunneled through a secure VPN-like channel. Well, in practice, instead of connecting directly over open internet, player traffic travels through a protected tunnel managed by EdgeMan, much like virtual private network, so-called VPN. This tunnel conceals the real IP addresses of the battle servers and keeps the connection path private. So as a result, this approach delivers both game cluster security protection and end-to-end acceleration. First, let's look at how this scheme achieves game cluster security protection. Well, actually, a transparent proxy server is deployed in front of the game cluster to hide the large pool of elastic game server addresses and aggregate them into a single IP for centralized protection. This means that even if the game clusters scales up or scales down, for example, due to fluctuations in number of players or active game rooms, and the public IP addresses are dynamically added or removed, we did not even need to adjust the protection strategy. So Edge1's edge-based DDoS protection, as we mentioned before, shields the entire game cluster, and the attack traffic is identified, scrambled, and blocked at the edge, and the customers only pay for clean traffic, helping to reduce protection cost. In addition, the SDK enables traffic signatures to enhance protection accuracy, achieving identification rate close to 100%. Well, that we will discuss in more detail shortly. The solution supports game cluster deployed within Tencent Cloud, outside Tencent Cloud, or in hybrid environments, as the proxy server can be deployed in any location. Now, let's see how the multi-channel security acceleration scheme enables full path security acceleration. Well, through the tunnel between the SDK and the transparent proxy server, we achieved end-to-end acceleration. At every segment of the network, acceleration is implemented through a multi-path redundancy strategy. On the mobile network side, we use smart routing to switch seamlessly between Wi-Fi and 4G or 5G, always choosing the best connection. Across the backbone network, we can leverage the Edge1 Layer 4 acceleration network, third-party lines, or public internet routes. For the origin fetching network, we support private deployment of proxy servers or deployment on Tencent Cloud's global nodes. This enabled accelerated traffic to pull content from nearby source, ensuring quality. And across the entire path, millisecond level fault tolerance ensures that data keeps flowing reliably. So even if one link has a problem, the business never feels an interruption. Next, in this slide, let's take a quick look at how the tunnel actually works. Edge1 offers a multi-channel security acceleration scheme using a client SDK and transparent tunnels. This approach establishes multiple simultaneous data channels between the player and the server. Well, actually, the idea is full path redundancy. Game data travels via several routes in parallel, and the fast, most stable path wins, much like sending package along multiple roads and using whichever arrives first. As I shown on the slide, the architecture uses a multipath setup with an acceleration gate. The client-side SDK works with this gateway to split and raise traffic across top international routes. All of this is transparent to the game itself, so no change to your game logic, yet it dramatically improves reliability. If one path experiences latency or packet loss, another delivers the data, assuring a smooth experience even across complex global networks. Well, in this slide, let's look at how the integrated traffic signature in the SDK, as I mentioned before, further enhance DDoS protection efficiency. Well, in simple terms, the game client tag each outgoing connection or package with a secret signature, a kind of a digital stamp via the integrated SDK. On the server side, Edge1 verifies these signatures. So, any traffic lacking a valid signature is instantly rejected. This means only traffic from legitimate, authorized game clients ever reach the battle server. So in short, the traffic signature assures that only genuine player traffic make it through, significantly strengthening DDoS mitigation without adding latency for real users. Finally, this slide highlights the acceleration logic that complements our security measures. While our Edge1 global network is vast, as shown in the slide, we have more than 300 and 200 global nodes and about 200 terabytes per second of total bandwidth. What that means for players is that they will connect to the game through the nearest available node, reducing latency right from the start. On top of this extensive infrastructure, we have developed full-stack acceleration components working behind the scenes. In practical terms, the network is continuously measuring connections quality and will intelligently route each player's traffic along the best path available. This is the so-called dynamic smart routing noted on the slide. If one route on the internet becomes congested or unstable, the system automatically switches to better paths in real time. This way, network fluctuations are avoided or smoothed out, and the data transmission stays fast and steady. So in short, this slide is emphasizing that our solution doesn't just protect against attacks, it also optimizes performance worldwide by leveraging a huge network of edge nodes and intelligent routing logic. We ensure players get a fast and stable gaming experience no matter where they are connecting from. So in conclusion, we hope this SDK solution can help you resolve issues with elastic game clusters, anti-DDoS, and also full-path acceleration. So next, let's go back to Zibo for more game scenario cases.
Okay, thank you. Now that we all covered the challenges and the solutions, let's look at real-world game scenarios where these capabilities have been applied successfully. For our first case, this is a two-dimensional shooting adventure game with over 3 million players pre-registered globally. At launch, each player downloads a 2 gigabytes package and can choose servers from multiple regions worldwide. For the game studio, the top priority was delivering a smooth, secure experience while defending against organized hacker groups like ACCN. With Edge1, we provided CDN download optimization, reserving 10 terabits per second bandwidth just for this game alone, fine-tuning caching and reducing region load. Game access acceleration using smart routing to speed up login, lobby, and payment across regions, and security protection, deploying advanced DDoS and CC attacks mitigations, and strict API controls and tailored port filtering. As a result, 3 things we are especially proud of is that 1.5, we have delivered 1.5 terabits per second peak download bandwidth. We have protected 812 gigabits per second peak DDoS attack, and also over 30 major attacks defended as well, without a single disruption to players. Here's another case. This customer runs a global game account management platform, handling everything from login to lobby management. It is based in Singapore. but serves players worldwide, meaning they needed fast accelerations, millions of QPS support, and a strong WAF protection. With Edge One, we have delivered dynamic HTTPS acceleration through globally distributed edge nodes and a dedicated line as well, cutting response latency by 37%. Robust DDoS mitigation, leveraging Tencent's 20 years of security expertise to defend against attacks up to 10 terabits per second. AI-driven WAF protection, blocking malicious traffic with zero false positives. So in short, millions of players can log in and play smoothly while the platform stays secure against even the largest global threats. So for this case, this customer is a well-known mobile game with millions of players worldwide. For them, latency is critical. Every action must happen within 60 milliseconds. And they also face massive DDoS threats targeting their battle servers. With Edge One, we combined L3 multicast acceleration and powerful DDoS mitigation. Anycast acceleration connects players to their nearest node while dispersing and filtering attacks traffic, defending up to 10 terabits per second. Layer 3 cleansing protects without requiring IP changes, filtering malicious requests before they even reach game servers. And dedicated backbone routes ensure ultra-low latency, keeping Southeast Asia players under 60 milliseconds, even during peak battles. So from the result, we have ensured a smooth real-time gameplay and reliable uptime even under large-scale attacks. And our last case here, this customer runs a global in-time marketing platform for events, promotions, and virtual item sales. They need under 1 second latency for millions of users worldwide, plus a strong anti-CC WAF bot management and DDoS protection to stop malicious scalpers and hackers. With Edge One, we have delivered global acceleration with dedicated transoceanic routes, ensuring stable and fast HTTPS requests. AI-powered WAF and bot detection, blocking malicious traffic with zero false positives, and layer 4 TCP accelerations to cut HTTPS handshake overhead, reducing request latency by 67%. The result is secure, seamless in-game events, even under heavy traffic and attack attempts. And of course, Edge One is trusted by many leading game companies around the world, from Riot Games activations to Netmarble, Garena, Krafton, and more. These partnerships show how our relationships with them and our solution are already powering some of the most popular games globally. So thank you for joining today's webinar. I hope these insights have shown Tencent Cloud can help you defend against the DDoS attacks. We look forward to helping you achieve success for your games. Now we are moving into the Q&A session. So I will start by picking 2 questions to answer. Okay, the first one, what is the main difference between Edge One layer 4 protection and anti-DDoS EIP? What are the use cases? A proxy-based approach. So your cloud resources don't have to be on Tencent Cloud. It works perfectly for multi-cloud environments. Anti-DDoS elastic IP, on the other hand, is more like a native protection, which means the origin servers such as virtual machines must be hosted on Tencent Cloud. So for my next question, just now you mentioned that not only battle servers, but even the lobby can be protected with Edge One, right? And the answer is, of course, yes. Edge 1 can provide protection at layer 3, 4, and 7. So it is suitable for virtually any scenarios. In addition, Edge 1 also offers edge computing capabilities, which can be integrated with other products in certain scenarios to enable more complex business logic.
So I noticed I got two questions for the SDK solution. Okay, my first question is for the SDK solution, will introducing the SDK have any impact on the existing game service? Well, the answer is no, because once the SDK is integrated, it intercepts traffic on the client side and works as a forward transparent proxy. Well, the forward transparent proxy means the original access method and track flow of your game remain unchanged. You can just imagine when you use a VPN, virtual private network, to visit a website or other service, no change need to be done neither on the client side nor on the server side. The next question is for the SDK solution, how does it protect battle servers, whether they are hosted on Tencent Cloud or elsewhere? Well, as I mentioned earlier, we actually hide the real battle servers behind a proxy server and use the Edge 1's edge-based protection to defend against DDoS attacks. Also, the proxy server can be deployed in or outside Tencent Cloud. So, no matter whether your battle servers are on Tencent Cloud or outside of it, we can leverage Edge 1's widely deployed edge protection nodes to disperse and mitigate attacked traffic effectively. Okay, that's all for my questions.